Today we will be expressing a whole number as a product of its prime factors. So you could represent whole numbers by writing them as products of their factors. Now factors are two numbers that when you multiply them together give you a certain product. So in this case we're working with 18. So one pair of factors would be 1 and 18 because 1 times 18 is 18. And then 2 and 9 are factors because 2 times 9 is 18. And 3 and 6 are factors because 3 times 6 is 18. And this is something we'll be doing a little bit later this year. So that's kind of an introduction to what's coming up. But what we want to do today is we want to write 18 as a product of just its prime factors, which means we're only going to use prime numbers, which means we cannot use 18, 9, or 6 because 18, 9, and 6 are not prime numbers. So what we would do if we wanted to write 18 as a product of its prime factors is we would have to break it down into its prime factors and then write our multiplication sentence. So our multiplication sentence for 18 would be 18 equals 2 times 3 times 3. If you get stuck, something that can help is to follow the advice of this young lady here and start dividing the number by its least prime factor and then continue dividing until the quotient is a prime number. And there are two methods that we can use to express a number as a product of its prime factors. And the first one is known as a factor tree. So with the factor tree, we start with the number we're factoring at the top, and then we're going to have two branches that come off. And those two branches represent the two numbers that we're going to choose that when we multiply them together will give us, in this case, 60. So since 60 is an even number, we know that we can multiply something by 2 to get 60. And we would be multiplying 2 times 30 to get 60. So 2 is a prime number, so I'm going to circle it because I don't need to branch off of that anymore. 30 is not a prime number, so I need to continue. 30 is also an even number, so I know 2 can be multiplied by something to get 30, and that would be 2 times 15. We've already established that 2 is a prime number, so I'm going to circle that because I can't branch off that anymore. But 15 is not a prime number. Now I cannot multiply anything by 2 to get 15, or any whole number by 2 to get 15. So I go up to my next prime number, which is 3, and I know that 3 times 5 is 15. And both 3 and 5 are prime numbers, so I am done there. The result that we'll be looking for is known as a multiplication sentence. And so I'm going to take that factor tree and I'm going to find those prime numbers and write a multiplication sentence using those prime numbers. So my multiplication sentence for 60 would be 2 times 2 times 3 times 5. And that is the only answer. Now you can put them in a different order. They don't have to be in this order, but I should be able to find 2 2s, a 3, and a 5 in your answer. But you could have your tree look differently, but you'd still get the same answer. So another example of a factor tree is we take 60, and we know that 6 times 10 is 60. Well, 6 is not a prime number, so I need to branch off of that. 10 is not a prime number, so I branch off of that. To get 6, it's 3 times 2, and both 3 and 2 are prime numbers. And to get 10, it's 2 times 5. 2 and 5 are both prime numbers. So once again, I get those 2 2s, a 3, and a 5, just like I did before. So that's a factor tree. Our other method is known as a factor ladder. So for a factor ladder, it's going to look very similar to division, but it's going to look like it's going upside down. So instead of putting the quotient on top of the 60, we're going to put it below the 60. With a factor ladder, you can only divide by prime numbers. So I cannot divide 60 by 10. I cannot divide it by 6 or 4 or 15 or 12 or 30 because those are all composite numbers. They are not prime numbers. So as we established earlier, 60 is an even number, so I can divide it by 2. 60 divided by 2 is 30. 30 is not a prime number, so I need to continue. I will take 30 divided by 2 to get 15. 15 is not a prime number. I'm going to divide it by 3 to get 5. So once again, I get 2 2s, a 3, and a 5. As we continue to work towards using algebra and math, we will start to see a slight difference in the way that we write multiplication sentences, and you can start using what's known as the multiplication dot. The multiplication dot would take place of the multiplication x, because as we move into algebra and we may start using variables, x is a very common variable, and using the multiplication x and x as a variable could get confusing, so you will start seeing the use of the multiplication dot. So we need to express 48 as a product of its prime factors, and we're going to use both methods here. We're going to use the factor tree and the factor ladder. So for the factor tree, I start with 48, and I just need to find any two numbers that when we multiply them together give you 48. So there are lots of different ways that your factor tree can look, but you should still end up with the same answer. So I know that 6 times 8 is 48, so I'm going to use 6 and 8. Maybe you use 2 and 24. Maybe you use 3 and 16. Maybe you use 4 and 12. You're going to get the same answer either way. 6 is not a prime number, so I'm going to break that down to 3 times 2, which are both prime, so I'm done there. 8 can be found by taking 2 times 4. 2 is a prime number. 4 is not, and you get 4 by taking 2 times 2. So my multiplication sentence for 48 would be 2 times 2 times 2 times 2 times 3. Now, if you are familiar with exponents and know how to correctly utilize exponents, you may use exponents here. But if you're not sure how to use exponents, that's fine. That is something we'll get to later, and you can write them out as it is. Okay. If I want to use the factor ladder, I start with 48, and remember, for the factor ladder, you can only divide with prime numbers. Well, 48's even, so I'll divide by 2, and that'll give me 24. 24 is not prime, it's even, so I'll divide by 2 again to get 12. 12 is not prime, so I'm going to divide that again by 2 because it's even, and that'll give me 6. 6 is not prime, and since it's even, I'll divide it by 2, and that'll give me 3. And that would be the same multiplication sentence that I have under my factor tree. I have those 4 2s and 1 3. So if I wanted to do the prime factorization of 78, and again, you can use either method. You can use the factor tree, you can use the factor ladder. I'm going to use a factor ladder on this one. And 78 might be one that you get stuck on. But if you notice, 78 is an even number, and all even numbers can be divided by 2. And if need be, go ahead and do the division off to the side. 2 goes into 7 3 times. 3 times 2 is 6. 7 minus 6 is 1. Bring down the 8. 2 goes into 18 9 times. 9 times 2 is 18. 18 minus 18 is 0. 39 is not a prime number. It's not an even number, so I can't divide it by 2. So the next prime number would be 3, so I'm going to see if 39 can be divided by 3. Now you might try this sometime and it may not work. If it doesn't work, then you move on to the next prime number, which is 5. If 5 doesn't work, try 7. If 7 doesn't work, try 11, and so on. But 39 is divisible by 3. 3 goes into 3 one time. 1 times 3 is 3. 3 minus 3 is 0. Bring down the 9. 3 goes into 9 3 times. 3 times 3 is 9. 9 minus 9 is 0. So I'll put a 3 here. I'll put 13 there. 13 is a prime number. And I need to finish with my multiplication sentence of 2 times 3 times 13. And again, it does not have to be in that order, but those should be the 3 numbers used in your multiplication sentence. If we want to do the prime factorization of 360, Well, I'm going to use a factor tree for this one, and the reason why, I see that 360 ends in a 0, and that tells me that I'm multiplying something by 10, and it's 10 times 36. And previously we established that 5 times 2 is 10, and so I've finished off those branches. To get 36, I can take 6 times 6, I could do 4 times 9, I could do 3 times 12, multiple options there. But either way, 6 is not a prime number, and I take 3 times 2 to get 6. And so my multiplication sentence for this one, 2 times 2 times 2 times 3 times 3 times 5. And again, it does not have to be in that order. And finally, 510. Well, 510 ends in a 0, so I will use the factor tree again because I know I can take 51 times 10. I know that 10 is 5 times 2, and I know that 51 is not a prime number. Well, I know 2 is not a factor of 51 because 51 is an odd number. So let's try 3. Let's see if 3 works. I have a strong feeling it does, but we'll try it anyway. 3 times 1 is 3. 5 minus 3 is 2. Bring down the 1. And 3 does go into 21 7 times. So it's 3 and 17. And 17 is a prime number. So my multiplication sentence for 510, 2 times 3 times 5 times 17. Well, as always with all these lesson videos, I hope it helps.